T for ambassador, and Bentham Science Publisher brand ambassador. It gives me immense privilege to invite Dr. S. Balakrishnan. Sir, please continue. You may take over the session.
Yeah. A very warm good morning to everyone. Thank you so much for your nice introduction, ma'am. It gives me a great pleasure for me to extend my wishes to all the participants. Manishji, can you share the screen? Manishji, are you there? Can you share the screen?
Sir, PPT is with you, sir?
Yes, sir. My screen is visible to you, sir.
No. What about others? Now I am seeing it. Yes.
Okay, sir.
Yeah, just make the slideshow.
Now it is on slide flow mode.
Yeah. So once again, very warm good morning to one and all present here. The today topic is machine learning using the generative adversarial network GAN. Before entering into the topic, that machine learning is an ever evolving field. So it can be easy to feel like you are out of the loop on the latest developments changing the world like that. So one of those emerging areas that have been getting a lot of buzz lately is we may say GAN, that is a generative adversarial networks. So the generative adversarial networks are an exciting recent innovation in machine learning. So that GAN is very, very important. It is a very exciting recent innovation in machine learning. And also we may say the GAN are a powerful class of neural networks. We are aware of that so many type of machine learning algorithm. So here this type of the GAN is a type of neural network that are used for the unsupervised learning. So mainly it's meant for unsupervised learning. So it was developed and introduced by Ian Goodfellow in 2014. So the GAN are basically made up of the system of two competing neural network models which compare with each other and are able to analyze, capture, and copy the various variations within a data sets. Please keep the same slide, slide number 2. Go to the slide number 2. Yeah. Just I'm giving the overview about that topic title. So the GAN have been used in generating images, videos, poems, some simple conversation like that. So another very, very important thing, we may say that the image processing. So the image processing is easy. Why? Because all animals can do it. But NLP, natural language processing, is hard, that only the human can do it like that. So for that, this is a very important. So the today topic, the overview of today presentation is, we'll start with the introduction, a machine learning overview of GAN structure. Then what about your first GAN? How you develop your first GAN using the Python, and impressive applications of GAN, and finally end up with the final thoughts. So this is the overview of today's session. So next slide, we'll go with that introduction. Next slide, please. Yeah. So the introduction, just go to that thing. Introduction, the generative model. Here the main game is to model the distribution of a given data set. So for the generative model that we are talking about today, the data set is usually a set of images. As already I told you, it may be an image or it may be any sort of things. So the poem, video, or some conversation like that. So usually in that data set is usually a set of images, but it would also be other kind of data like audio samples or time series data like that. So whenever we are focusing about the generative model, the generative model, there are two ways to go about that, getting a model of the distribution, either implicitly or explicitly. Just the implicitly is nothing but. So what's the difference? Implicitly and explicitly, we'll see what's the difference between these two. Within that first we'll see, we'll go with that explicit generative model. With an explicit generative model, you have the probability density. That's a very important. You have the probability density at your disposal. So we can model all the variations from the distribution directly. That's a very important. So I will repeat once again. The explicit generative model, it's nothing but here you have the probability density. So the probability density at your disposal. So here we can model all the variables from the distributions directly. That's why it's called as an explicit generative model. Second model is an implicit. Whereas in that implicit generative model, here you have to sample. So sample data should be needed in order to get a sense of our model distribution. So that is the thing. That's why it's implicit and explicit. Implicit in the sense you have to sample in order to get a sense of our model distribution. Whereas it in the explicit generative model, here you have the probability density at your disposal. So based on that, we can model all the variables from the distribution directly. So that's mainly happening in that implicit and explicit generative model. So when we are evaluating any generative model, either explicit or implicit, one way to do that, we actually which happens to look very good in paper, that is whenever we are using the images or like that. So we can sample from our model distribution and then visually inspect the samples to see how well they match up with the original, with our original data, like that. So that's why the implicit generative model and explicit generative model is very important model. So the closer our sample images are to training the images, that is the better our model is. So next, what are the types of generative model? So in the context of deep learning, when we talk about the generative model, we are usually talking about one of the four kind of model. The first model is go to the previous slide. Yeah, the first model is auto-regressive. So as per that generative model types, so in the context of the deep learning, first type is auto-regressive. So with the auto-regressive model, you generate an image. So you may generate an image by generating each pixel conditioned on the previous pixel that you have generated. That's why it's called as auto-regressive. So I will repeat once again, the auto-regressive. So these four types is very important whenever we go for considering about that GAN model, that's a generative model. As per that context of the deep learning, this four model is very important. The first model is an auto-regressive model. So as per that auto-regressive model, you can generate an image by generating each pixel conditions on the previous pixels that you have generated previously. So that's why. So based on that, it will be generated. Second important thing is a reversible model. As per the reversible model, so the concept of the reversible model is to take a GAN, but make the generator process reversible. That's a very important point. So whenever we are focusing about the reversible model, here the concept of the reversible model is to take a GAN. So that is a generative adversarial network, but it makes the generator process reversible. So that's a thing. So this means we can pass the images and a noise both ways through a reversible model. It may be from going from noise to image or from image to noise, like that. So that's why it's called as a reversible model. It will taking the things, it passes the images and noise both the way through the reversible model. That is, it is going from noise to image or image to noise, like that. Third important model is a type of generative model is the variational autoencoders. As per that, we may say VAE, that is a variational autoencoder. VAE, the short term of that variational autoencoder is a VAE. So as per that variational autoencoder VAE, here the autoencoder consists of pair of connected networks. So the network may be consist of encoder and a decoder. So as per that name itself. So the variational autoencoders are distinguished by having a continuous latent space. That's a very important thing in the variational autoencoder. It's distinguished by having a continuous latent space. So this allow for easy sampling and interpolation. So which is particularly useful when that variational autoencoder models are used to explore the variations on pre-existing data in a specified direction. So that is an important thing in that variational autoencoder. So the fourth important type is the generative adversarial network. So that is our topic. So as per that generative adversarial network, now after traversing through other generative model from autorecursive, reversible, variational autoencoder, we get to that GAN or the generative adversarial network. So in the upcoming slide, in the upcoming thing, we will see what is the generative adversarial network. So apart from generative adversarial network, we are having other three generative models, that is autorecursive, reversible, and variational autoencoders. So next slide, please. Next slide. Slide number 5. Yeah. Slide number 5. Slide number 5, please. Yeah. So next very important thing, the difference between discriminative and generative model. If you have studied the neural networks, then most of the applications you have come across were likely implemented using the discriminative model. That's a very important point. Just keep in your mind. If you are doing research related to machine learning, if you have studied any neural network, then the most of the applications you have come across were likely implemented using the discriminative model only. But here the generative adversarial network, on the other hand, are the part of the different class of that models, it known as the generative model. So as per that, here the discriminative models are those used for most supervised classification or regression problem. As an example of that classification problem, suppose you like to train the model to classify the images of handwritten digits from 0 to 9 like that. So for that, you have to use that use a labeled data set containing images of handwritten digits and their associated labels indicating so the associated labels indicating which digits which digit each image represents. So the next slide, please. So as per that diagram, next slide. Yeah. So here, as per that discriminative model, here during the training, go to the next. During the training process, you would use an algorithm to just adjust that model's parameter. So some algorithm is useful for adjusting the model's parameter. So the goal would be the minimize the loss function so that the model learn the probability distribution of the output given the input like that. So here, as per that, here the training sample is given. We are giving the input in the discriminative model. So we are predicting something. The prediction is we are getting the output is 5 like that. So here after the training phase, you would use the model to classify a new handwritten digit image by estimating the most probable digit the input correspond to, that is illustrated in that figure like that. That is a training sample is given. So here the 0 to 9 different numbers is given. So So we are giving some input, so that input will be trained with the training symbol like that. So we are getting the output like that. So next slide. Slide number 7. Slide number 7.
So there is a network delay. There is a
Yeah,
network
yeah.
delay.
No problem. No problem. Yeah. So here, same the discriminative versus generative model. So already I told you that based on the neural network, the other structure can be used as a discriminative model, such as yeah. So here mainly we are using two types. One is a logistic logistic regression model and a support vector machine. So that is the two important algorithm we are using: logistic regression and the support vector machine. That is the important thing. So next slide, please. Yeah. So like generative models like GAN. However, these models are trained to describe how a data set is generated in terms of the probabilistic model. So already I told you GAN is very important. That is here the probabilistic based on that probabilistic model. So by sampling from a generative model, you are able to generate the new data. So while discriminative models are used for supervised learning, here the generative models are often used with unlabeled data sets, and it can be seen as a form of the unsupervised learning. That's why already I told you that generative model is mainly based on that unsupervised learning. So next slide. Yeah. So here consider this example. Here they're using the data sets of handwritten digits. So some digit is given. So you would train the generative model to generate the new digits. Actually, as per the previous discriminative model, we are having the training symbol and we are giving some input. So based on that input, we are getting the output. But here, as per that generative model, here the training sample is given, but the input we are giving the random data. So based on that random data, it generates the generative model. Why? Because it's based on the probabilistic model. So based on that probabilistic, it will generate the some. It will based on the generative model, it will generate some sample. So that's why here they're using the data sets of the handwritten digits. You train a generative model to generate the new digits. So during the training phase, you would use some algorithm to adjust the model parameter to minimize the loss function and learn the probability distribution of the training set. So then with the model trained, you would generate the new sample. So that sample is illustrated in the following figure. Why? Because we are giving the random data. So based on that random data, it will generate some random value. So that's happening in that generative model. That's why the generative model is mainly based on the probabilistic model like that. So next, the generative model architectures. The example structures are, we may say the Boltzmann machine, variational autoencoders, hidden Markov model. So these are the things. It's based on the generative model. So next slide. Slide number 9. Slide number 10. Yeah. So the generative model architectures, mainly we are using the Boltzmann machine, variational autoencoders, hidden Markov model, then model that predict the next word in the sequence like GPT-2 like that. So these are some of the examples. So best architecture based on the generative model architecture. So next slide. Yeah. So here why were the GAN developed in the first place? Why were that generative adversarial network developed in the first place? So it has been noticed most of the mainstream neural networks or neural nets can be easily fooled into the misclassifying things by adding only a small amount of noise into the original data. Go to the previous slide, slide number 11. Here, why were that GANs developed in the first place? It has been noticed. Slide number 11. Yeah. So that is a very, very important thing. Why were that GAN developed in the first place? Already I told you one of the main neural network, mainstream, that is, it has been noticed most of the mainstream neural networks can be easily fooled into misclassifying the things by adding only a small amount of noise into the original data like that. So surprisingly, the model, the original that model, the generative model, after adding the noise, has a higher confidence in the wrong prediction than when it predicted correctly. That's a very, very important. That's happening. The model after adding the noise, that unwanted noise, a small amount of noise, has a higher confidence in the wrong prediction than the when it predicted correctly. So the reason for such adversary is that the most machine learning model learn from a limited amount of data, which is a huge drawback as it is prone to overfitting like that. So, the reason for slide number 11, the reason for such adversary is that most machine learning models learn from a limited amount of data. That's a very important thing, which is a huge drawback, and it's a prone to overfitting. That's happening. So also the mapping between the input and the output is almost linear. That's a thing. So although it may seem that the boundaries of separation between the various classes are linear, but in reality they are composed of the linearities, and even a small change in a point in the feature space might lead to the misclassification of data like that. So that's why were the GANs developed in the first place. So that's the purpose of that GAN. So next is that is the next one, the machine learning overview. So here we'll see about overview of that machine learning. It's relevant to that our GAN model. So that is machine learning is a subfield of computer science that give the computers the ability to learn without being explicitly programmed like that. And another thing, we may say the computer program is said to learn from the experience E with respect to the sum class of the task T and performance measure P. So if its performance at the task in T as measured by the performance measure P, it improves with experience E like that. So machine learning is nothing but it's a branch of artificial intelligence. It concerned with the design and development of algorithms. That's the thing. It's concerned with the design and development of algorithm that allow the computers to evolve behaviors based on the empirical data. That's a very, very important. I will repeat once again. The machine learning is a branch of artificial intelligence. It concerned with the design and development of algorithms, so mainly that allow the computers to evolve the behaviors based on their empirical data. That's a very important thing. So as the intelligence require knowledge, so whenever we may say that the intelligence require knowledge, and it is necessary for the computers to acquire that knowledge also. So that acquiring knowledge that will be happening with the help of that machine learning. That's a very important thing. So next slide. Yeah. So here, taxonomy of machine learning based on the learning style. There are so many algorithms. We may say there are so many algorithms that it can feel overwhelming when the algorithm names are thrown around, and you are expected to just know what they are and where they fit like that. So these 2 points. Whenever we go for choosing that algorithm or algorithm name, we are supposed to expect to just know what they are and where they fit like that. So these 2 points is very important. What they are, what is the purpose, what is the purpose of that algorithm, and that's why the what they are and where they fit like that. So I want to give you two ways to think about and categorize the algorithm. So you may come across in the field like that. So the first is a grouping of algorithm by their learning style. That's a very important thing, based on the learning style. Second important thing, second is a grouping of algorithm by their similarity. So similarity in the form of or function. That is we may say like grouping similar animals together or like that. So the both approaches are useful, but we will focus in one of the focus on the grouping of algorithm by similarity and go on a tour of a variety of different algorithm types like that. So the based on their learning style. So here 3 different learning styles. See, already I told you based on the learning style and based on the similarity, we are comparing the algorithm. We are deriving the algorithm in the machine learning. 2 important parameters, that is a learning style and similarity. The first, based on the learning style, that algorithm is divided into 3 to 4 category. The first one is a supervised learning. So as per that supervised learning, here the input data is called the training data, and it has a known label or some sort of result. We may say such as the spam or not spam or a stock price at a time like that. Yeah. So here a model is prepared through a training process in which it is required to make a prediction and it's corrected when those predictions are wrong. That's a very important in the supervised learning. So the supervised learning, the training process continues. See, that's the purpose of the supervised learning. So the training process continues until the model achieves the desired level of accuracy on the training data. That's why here the learn through the example of which we know the desired output, that is what we want to predict. Example here we are giving is this is a cat or a dog. So some diagram based on that diagram we have to predicate whether the object is a cat or dog. So next, are these emails or spam or not? So just we are having the set of email. So from that mail we have to identify, we have to predicate whether the mails are spam or not like that. So the next important thing is to predict the market. That's the thing. So the types of the supervised learning, here we are having the 2 important types. So classification and recursion. So as per that classification, here the output is a discrete variable. That is either a cat or dog. That is a discrete. As per that classification, the output is a discrete variable. But as per the recursions, the output is a continuous. So it may be the price may be continuous process, the temperature may be a continuous process like that. So that's why the example problem of the classification of the recursion, here the example algorithm include the logistic recursions and the back propagation neural network algorithm like that. So that belongs to the classification and the recursions algorithm. So next slide. Next one is the unsupervised learning. Yeah. So second, next type based on this learning style is unsupervised learning. So as per that unsupervised learning, here input data is not a labeled one and it does not have any known. Go to the previous slide, slide number 16. Yeah. So as per that unsupervised learning, here we may say the input data is not labeled one, and it does not have any known result. But the supervised, we may have the known result, but until unless we are getting the correct exact output, that training is will be going on like that. But here the input data is not a labeled one and does not have a known result like that. So here, as per that unsupervised learning, here a model is prepared by detecting the structures present in the input data. So this may be to extract the general rules. So it may be through a mathematical process to systematically reduce redundancy, or it may be to organize the data by similarity. So here that's why in the unsupervised learning there is no desired output. So we have to learn something about the data. So that's the thing that's happening. So that's why this relationship is called as a latent relationship. Here I have the photos and want to put them in 20 groups. So just I am making the collections. So in that case, that's why mainly we are using here the clustering algorithm. So here this as per the unsupervised learning, here it will be useful for learning the structure in the data. Say clustering or some hidden correlations or reduce the dimensionality, etc. So here the example problem are, as per that unsupervised learning, the example problems are, we may say the clustering. Another very important thing is the dimensionality reduction and association rule learning. So these are some of the example problem belongs to the unsupervised learning. And the example algorithm include that as per the unsupervised learning, some example algorithms are Aberrari algorithm and K-means algorithm. So these are some of the algorithm belongs to the unsupervised learning. So next, third important types of learning style algorithm is the reinforcement algorithm or reinforcement learning. Slide number 18. Yeah. So third important thing is the reinforcement learning. As per that reinforcement learning, it's defined as a machine learning method. So reinforcement, supervised and unsupervised is a normal that as per that learning style. But the reinforcement is defined as a machine learning method that's concerned with how the software agents should take the decision or should take the action in an environment. That's a very important thing. Whenever we are focusing about the reinforcement learning, here the software agent is very important. So the software agent is nothing but like normal agent, ticket programming agent, or so many type of agents are there like that. Here the software agents is getting some input based on the environment, it will produce some output. So that's the thing. Suppose if you go for railway ticket in the sense, as per the railway ticket agent, only we are getting the railway ticket alone. So like that. So that's why based on that reinforcement learning algorithm, it's defined as a machine learning method or machine learning algorithm that is mainly concerned with how that software agents should take the action in an environment. So the reinforcement learning is a part of the deep learning method that helps. Go to the previous slide, slide number 18 only. So the reinforcement learning is a part of the deep learning method that helps you to maximize some portion of the cumulative reward. That's the thing. That's why the reinforcement learning is the best thing. So that's why you see the agent interact with an environment and watches the result of the interaction. So here the environment gives a feedback via the positive or negative reward signal. That's the thing. So as per that reinforcement learning, this neural network learning method helps you to learn how to attain a complex objective. That's a very important thing in the reinforcement learning. How to attain a complex objective or maximize a specific dimension over many steps like that. So that's a the reinforcement learning is very important algorithm compared to the previous two algorithms. So what are the important characteristics of reinforcement learning? We may say first important features or characteristics of reinforcement learning is there is no supervisor, only a real number or reward signal will be there. Second important characteristics, it's a sequential decision making. So that's one after another, the sequential decision making will be there. And here, the time plays a crucial role in the reinforcement problem. That's the thing. The time is a one important factor. That is a one, we may say it's a one drawback also. So the feedback is always delayed, not instantaneous. That is also, and the agent's action determines the subsequent data it receives the information like that. So just to consider the typical reinforcement learning scenario, already I told you that is a agent. So the agent, it is an assumed entity. The agent is an entity which performs the action in an environment to gain some reward. That's the thing. That's a very, very important thing. We may already so repeat once again. The agent is an entity. So agent we may say the agent is a software entity which performs the action that is performing some actions in an environment. So the what type of environment, based on that environment, the action will be performing to gain some reward. So that's mainly happening. So here the environment is nothing but it's a scenario. The environment is a scenario that an agent has to face like that. And the reward is nothing but an immediate return given to an agent when he or she performs the specific action or task. That is the thing. The state is nothing but it refers to the current situation returned by the environment. So what type of what situation or what status or like that, that will be given by the state like that. Apart from that, here we are having the value policy, value function, model of the environment, model-based method, like that. So here that is a thing. So here the next important thing, because the reinforcement learning is very, very important based on our generative GAN model, generative adversarial network model. That's why I'm mainly focusing about the reinforcement learning taxonomy as defined by that OpenAI. So here it's actually the reinforcement learning algorithm is based on the model-free reinforcement and model-based reinforcement learning. So whenever we are focusing about the model-based reinforcement learning, it uses the experience to construct and so as per that model-based reinforcement learning, mainly it uses the experience to and immediate outcomes in the environment. That's very important. That's why it's called as a model-based reinforcement. So as per that model-based reinforcement learning algorithm, it uses the experience to construct an internal model of the transitions and the intermediate outcomes in the environment like that. So here appropriate actions are then chosen by searching or planning in the world model. So that's why we are using some searching algorithm or planning algorithm for making that model-based reinforcement learning for getting an appropriate action. So that is very, very important in the model-based reinforcement learning. So next thing is a model-free reinforcement learning. As well, model-free reinforcement learning, we may say, on the other hand, it uses the experience to learn directly one or both of two simpler quantities. That's a very, very important. That's why it's a model-free. As per that model-free reinforcement learning, it uses the experience to learn directly one or both of two simpler quantity. The quantity may be a state, or it may be an action value, or it may be a policy like that. So which can achieve the same optimal behavior, but without estimation or use of the world model like that. So that's why that is a model-free reinforcement. We'll repeat once again. The model-based reinforcement algorithm mainly uses the experience to construct an internal model of the transitions and immediate outcome in the environment. That will be happening in immediate outcome. That's the main important thing in that model-based reinforcement. But as per the model-free reinforcement, it uses the experience to learn directly one or both of the two simpler quantity. So the simple quantity may be a state or action value or some sort of policy like that. So as per the model-free reinforcement, given a policy, here a state has a value is defined in terms of the future utility that is expected to occur that starting from the state like that. So the model-free reinforcement learning methods are statistically less efficient than model-based method because information from the environment is combined with the previous, and possibly some erroneous will be there, estimates or beliefs about state values rather than being used directly. So based on that, that is a difference between model-free and model-based. So the model-free reinforcement learning having the policy optimization and Q-learning. As per the policy optimization, we are having different algorithm, policy gradient, A to C, A3C, PPO, TRPO, and TDBC, that is DD3, SAC, like that. As per that Q-learning, we are having TQMC like that. So these are some of the algorithms. So if you go for doing any sort of research, either based on the model-based or model-free-based reinforcement learning, you may use these are the algorithms. So many algorithms are available. You may use for your research-oriented research purpose. So it will be very useful for you. Alpha 0, I2A, MBVE, like that. So these are some of the reinforcement learning taxonomy as defined by the OpenAI, like that. Next slide, please. Yeah. So the fourth important thing, semi-supervised learning. So as per the semi-supervised learning, here the input data is a mixture of labeled and unlabeled. That's the thing, a combination of both supervised and unsupervised. That is the labeled and slide number 21. Yeah. So the labeled and unlabeled example. So the semi-supervised machine learning algorithm is a combination of supervised and unsupervised machine learning. That's why it's called as a combination of labeled and unlabeled example, like that. So here there is a desired prediction problem, but the model must learn the structures to organize the data as well as make the predictions, like that. So that's a very important thing. So as per that semi-supervised learning, here the example of the semi-supervised learning example problem are, we may say the classification and the recursion. So because both the supervised and unsupervised, so we may use the classification and recursion. So go to the previous slide, slide number 21. Yeah. So here, example algorithms are extensions to other flexible methods that make the assumptions about how to model the unlabeled data. So as per using either labeled or unlabeled examples or unlabeled data. So based on that, we are finding the flexible method and make the assumptions about how to model the unlabeled data, like that. So with more common supervised machine learning method, you train a machine learning algorithm on a labeled data set in which each record include the outcome information, like that. So this allows the algorithm to reduce the patterns and identify the relationship between your target variable and the rest of the data sets based on information it already has. So in contrast, already we have seen supervised, semi-supervised, unsupervised reinforcement like algorithm. So in contrast with that unsupervised learning algorithm, here learn from the data sets without the outcome variable. But in semi-supervised learning, the algorithm learn from a data set that include both the labeled and unlabeled data. That's usually mostly we are using the unlabeled data only in the semi-supervised learning. And another very important thing, why semi-supervised machine learning is important. So like reinforcement learning, see the reinforcement learning, we are getting the exact reward based on the environment. So the action will be performing. That's why that reinforcement learning is the best algorithm, best thing for that machine learning. But why the semi-supervised machine learning is important? So as per that, when you don't have enough labeled data to produce an accurate model, and you don't have the ability or the resources to get more data, so you can use the semi-supervised techniques to increase the size of your training data. That's a very important. So they may ask some interview question why that semi-supervised machine learning is very important in the sense whenever you don't have the enough labeled data to produce an accurate model, and you don't have the ability or resources to get more data, or you can use semi-supervised techniques to increase the size of your training data like that. So for example, imagine you are developing a model, we may say some example intended to detect a fraud for a large bank. In that case, some fraud you know about, but other instances of fraud are slipping by without your knowledge. So in that case, you can label the data sets with the fraud instances you are aware of, but the rest of your data will remain unlabeled like that. So that is a semi-supervised learning. So that's why the semi-supervised learning is all the way. It's important for you to make the thing. Suppose if you whether your data is labeled or unlabeled, even in that cases, either labeled or unlabeled, easily we can use it with the help of the semi-supervised learning. That's why the semi-supervised learning algorithm is very, very important algorithm. So as per that research concern, even you can go with that semi-supervised learning based on your applications. So next slide. Slide number 22. Yeah. So far we have seen about the algorithm derived based on the learning style. So algorithm derived by the learning style based on that learning style we are having supervised, unsupervised, semi-supervised reinforcement learning algorithm. So this slide mainly focusing about the algorithm grouped by the similarity. So algorithms are often grouped by the similarity in terms of their function. That's similarity in go to the previous slide, slide number 22. Yeah. So here the algorithms grouped by similarity. So the algorithm, the grouped by similarity in the sense it's nothing but in terms of their function. In terms of their function in the sense how they work, how that thing will be working based on the function like that. For example, here mainly we may say the tree-based method and neural network inspired methods. These are some of the algorithm, and I think this is the most useful way to group the algorithm, and it is the approach we will use here. So this here the mainly the algorithm grouped by similarity. The first algorithm is the recursion algorithm. So as per that recursion algorithm here, we may say before that we what is how we are grouping by the similarity. So here there are still algorithms that would just as easily fit into the multiple categories like the learning vector quantization. That is both a neural network inspired method and an instant based method like that. So there are also categories that have the same name that describe the problem and the class of algorithms such as the regressions and clustering. So the algorithm grouped by the similarity, we are having the regressions and the clustering algorithm. So we would handle these cases by listing the algorithm twice or by selecting the group, that subjectively is the best fit. We may say that is a best fit. So I like this later approach of not duplicating the algorithm to keep these things simple. So in this section, in this slide, in the slide number 22, we list many of the most popular learning algorithm grouped by the way we think it's the most useful one. So the list is not the exhaustive in either the groups or the algorithm, but I think it's a representative, and it will be very useful to you to get an idea of the layout of the land like that. So please note that in the regression algorithm, there is a strong bias towards the algorithm used for classification and regressions. The two most prevalent supervised learning algorithm problem you will encounter. So for the regression algorithm, as per that regression algorithm, regression is concerned with modeling the relationship between the variables. That's a very, very important. The regression algorithm is concerned with modeling the relationship between variables that is iteratively refined using a measure of error in the predictions made by the model. So the regression methods are a workhorse of the statistics and have been co-opted into the statistical machine learning. That's a very important thing. As per that, regression algorithm is the regression methods are the workhorse of the statistics and have been opted into the statistical machine learning like that. So this may be confusing because we can use the regression to refer to the class of the problem and the class of the algorithm like that. So really the regression is nothing but it's a process. So just keep in your mind, the regression is nothing but it's a process. So as per that regression algorithm, we are having different types of algorithm: ordinary least square regressions, linear regressions, logistic regressions, stepwise regressions, multivariate or adaptive regressions, splints, locally estimated scatterplot smoothing like that. So these are some of the algorithm belongs to that regressions. So next slide. Yeah. So next important algorithm based on the similarity is the instant-based algorithm. So the instant-based learning. Next slide. Instant-based learning model is a decision problem. Yeah. The instant-based learning algorithm is a decision problem with the instances or example of training data that are the deemed important or required of the model. So as per that instant-based algorithm, the instant-based algorithm or model is a decision problem with the instances or examples of training data. So that is a very important, the training data. So that are deemed important or required to the model. So such methods, the instant-based methods are typically build up a database of example data and compare new data to the database using the similarity measure. That's why it's a similarity algorithm measure in order to find the best match and make a prediction like that. So that's a very, very important behind that instant-based algorithm. So as per that instant-based algorithm, the main idea behind that instant-based algorithm is it build up a database of example data and compare the new data to the database using a similarity measure in order to find the best match and make a predictions like that. So for this reason, the instant-based algorithm or method are also called as the winner-take-all methods. The instant-based excuse me. So the instant-based algorithm is also called as winner-take-all methods and memory-based learning algorithm also. Why? Because it's all the way it will taking the winning model. That's why it's and also it's using some memory for storing the data, comparing the data with the already existing thing. That's why this instant-based method is also called as the winner-take-all method, or also called as the memory-based learning method. So main focus behind this instant-based learning is to put on the representation of the stored instances and the similarity measures used between the instances. So as per that instant-based algorithm, some of the algorithm we are using it: k nearest neighbor, learning vector quantization, self-organizing map, and a locally weighted learning algorithm and support vector machine. So these are some of the yeah. So these are some of the algorithm belongs to that instant-based algorithm. So next one. Slide number 24. Yeah. So next important algorithm is a regularization algorithm. As per that regularization algorithm, here the extension made to another method. It means typically that is recursion method that penalizes the model based on their complexity, favoring simple model that are also better at the generalizing. So here I have listed some regularization algorithms separately here because they are the popular as well as the powerful, and also generally simple modifications made to each other method like that. So the best algorithm based on the regularization algorithm is the ridge regression, least absolute shrinkage and selection operator, elastic net, and least angle recurrence like that. So these are some of the algorithm for the research purpose. We may use the regularization algorithm also. So next, apart from these three, that is so far we have seen about the regularization algorithm, that instant-based algorithm, recurrence algorithm. So apart from that, some other algorithms also there. So next slide, we'll see what are the other algorithm based on the similarity action. Yeah. So other algorithm, slide number 25. Yeah. Other algorithm, first algorithm is a decision tree algorithms. So as per that decision tree algorithm, here the decision tree method construct a model of decisions it made based on the actual values of attribute in the data. That's a very, very important. Excuse me. So here the decision tree method construct a model of decisions made the decision made based on actual values of attribute in the data. So here the decisions forth in a tree structure until a prediction decision is made for a given record. So here the decision tree are the trained on the data for the classification and regression problem. So the decision trees are often fast and accurate and a big favorite in the machine learning algorithm. So that's a very important thing in the decision tree algorithm, the first type of algorithm, decision tree algorithm. So the most popular decision tree algorithms are, we may say, the classification and regression tree, CART algorithm, iterative dichotomizer tree, ID3 algorithm, C4.5, C5.0 algorithm, decision stump algorithm, M5 algorithm, conditional decision tree algorithm. So these are the some algorithm belongs to the decision tree algorithm. So second best algorithm belongs to that similarity action is the Bayesian algorithm. So the Bayesian algorithm, these are the methods, those that explicitly apply the Bayes theorem. That's a very, very important. That's a probability. That's a Bayes theorem for the problem, such as classification or recurrence. So the most popular Bayesian algorithms are, we may say, naive Bayes algorithm, quasi-naive Bayes, multinomial naive Bayes algorithm, Bayesian belief network, Bayesian network algorithm. So these are the algorithms very, very useful for the statistical methods. So that is the second best algorithm. That is a Bayesian algorithm. So third algorithm is a clustering algorithm. Here the clustering like that recurrence, it describes the class of a problem and the class of the method. As per that, clustering methods are typically that are organized by the modeling approaches such as centroid based and hierarchical method. All methods are concerned with using the some sort of inherent structures in the data to best organize the data into the groups of maximum commonality like that. So the most popular clustering algorithms are, we may say, k-means, k-medians, expectation maximization algorithm, hierarchical clustering algorithm. So these are some of the algorithm belongs to the clustering algorithm category. So fourth important algorithm is the association rule learning algorithm. So as per that association rule learning algorithm, the association rule learning method, it just extract the rule. So the mainly the extraction will be happening. So they extract the rule that best explain observed relationship between the variables in data. So these rules, this extraction of rule, these rules can yeah, these rules can discover the important and commercially useful associations in large multidimensional data sets. So that can be exploited by an organization like that. So the most popular association rule learning algorithm is the Aberradi algorithm and the Eclat algorithm. So these are some of the algorithm. So next, fifth important algorithm is the artificial neural network algorithm. So as per that ANN, that is artificial neural network algorithm or the model, that are inspired by the structure and or the function of the biological neural networks like that. So they are a class of pattern matching that are commonly used for regression and classification problem, but are really an enormous sub field comprised of hundreds of algorithms and variations for all the manner of the problem types like that. So note that here I have separated out that deep learning from the neural network because of the whenever the artificial neural network we are using the here mainly for the deep learning purpose. So deep learning from the neural network because of the massive growth and popularity in the field. So how we are concerned with this more classical method like that. So the most popular artificial neural network algorithms are the perceptron, multi-layer perceptron, backpropagation, stochastic gradient descent algorithm, Caulfield network, like that. So next is sixth important algorithm is a deep learning algorithm. As per the deep learning method, deep learning methods are a modern update to the artificial neural networks that exploit the abundant cheap computations. So that's the thing. So they are concerned with building much larger and more complex neural networks. And as commented on above, many methods are concerned with very large data sets of labeled analog data such as image, text, audio, and video like that. So most of the algorithm belongs to deep learning algorithms are convolutional neural. That is a very, very important. That's all the way we are using for in the deep learning. That is a convolutional neural network, recurrent neural network, long short-term memory network, stacked autoencoders, deep Boltzmann machine, and deep belief network like that. So next is seventh important algorithm is the dimensionality reduction algorithm. As per that dimensionality reduction algorithm, this algorithm like a clustering method. The dimensionality reduction seek and exploit the inherent structure in the data. That's a very important thing. It seek and exploit the inherent structure in the data. But in this case, in an unsupervised manner, or in order to summarize or describe the data using less information like that. So this can be useful to visualize the dimensional data or to simplify data which can then be used in the supervised learning method like that. So many of these methods can be adopted for use in the classification and regressions like that. So the best example algorithm belongs to the dimensional reduction are principal component analysis, principal component regressions, multi-dimensional scaling, projection pursuit, linear discriminant analysis, flexible discriminant analysis, so like that. So eighth important algorithm is the ensemble algorithm. That's the ensemble methods or the method model. It mainly composed of the multiple weaker model that are it's independently trained and whose predictions are combined in some way to make the overall predictions like that. So that's a very important, that's the thing in the ensemble method. The ensemble method or the model is composed of the multiple weaker model that are independently trained and whose predictions are combined in some way to make the overall predictions like that. So much effort is put into what types of weak learner to combine and the ways in which to combine them. So this is a very powerful class of technique, and also it's a very popular like that. The ensemble algorithm is a very powerful class of technique and very popular also. So as per that ensemble learning algorithm, here we are using so many algorithms. Example algorithms are boosting, backing, ADA boost, stacked generalization, random forest algorithm like that. So the last type of algorithm is the we may say other machine learning algorithm like that. So as per that other machine learning algorithm, here the many algorithms were not covered so far. It's not at all covered. So I did not cover the algorithm from specialty task in the process of machine learning, such as we may say the feature selection algorithm, algorithm accuracy evaluation, performance measure, optimization algorithm like that. So, and also I did not cover the algorithm from specialty subfield of the machine learning, such as we may say the computer vision, natural language processing, recommender system, reinforcement learning, graphical model, and so on. So So these are the overview of that machine learning algorithm based on the similarity and based on the learning style. So that's a very important for your research purpose. It will be very useful for you. Just you can choose which algorithm is better for your research like that. So next we'll go to that overview of GAN structure. So as per that GAN, that is Generative Adversarial Network. Whenever we are focusing about the adversarial network, it has the two parts. That is, one is a generator and another thing is a discriminator. First, we will see about the generator. So that is a very important. Two term or two parts is very important. Generator and discriminator. The generator is nothing but it learns to generate plausible data. So that's a very important thing. Generator learns to generate plausible data. So the generator instances become negative training example for the discriminator. So just make a note. Actually, as per the GAN structure, we are having the two parts: generative and discriminative. Generator is nothing but it learns to generate the plausible data, but the generated instances become the negative training example for the discriminator. So the discriminator is nothing but it learns to distinguish the generator's fake data from the real data. So the discriminator penalizes the generator for producing the implausible result. So as per the example, the figure 1, just to consider figure 1, we are having the generated data, discriminator and real data. So when training begins, whenever we started training, the generator produces, obviously it's a fake data, and the discriminator quickly learns to tell that it is a fake like that. Why? Because real data is there, the generated data, just we are doing something, but it's not related to that real data. So whenever the training begins, the generator produces obviously the fake data. Why? Because as per that generator, it generates the fake data. How it generates the fake data in the sense, based on the real data, the checking will be performing, and the discriminator quickly learns to tell that it's a fake like that. So that's happening in the first figure. As per the second figure, see here, as the training progresses, here the generator gets closer to the producing output somewhat. But if, that can fool the discriminator like that. So that's why again he is taking the fake data like that. But as per the figure 3, finally, if the generator training goes well, so as per that the generator and discriminator, as per the figure 3, the figure 3 final, as per the figure 3, if the generator training goes well and the discriminator gets worse at telling the differences between the real and fake. So the real as well as the fake, and automatically it start to classify the fake data as real, and its accuracy decreases like that. So based on that here, based on the generator and discriminator, the third figure it will produce the exact output, that is a real data like that. So that is the overview structure of that GAN. So the generative adversarial network is working like that. It's mainly based on the two parts, that is the two important features. One is the generative and another thing is a discriminator. So generator, in the sense, it learns to generate the possible data, and that generated instances become the negative training example for the discriminator like that. But as per the discriminator discriminator learns to distinguish the generator's fake data from the real data. So the discriminator penalizes the generator for producing implausible result like that. So that's happening in that GAN structure. So next slide. Yeah. So here the diagrammatic representation of GAN. See here, generator is there, discriminator is there. So already we know about what is generator and what is a discriminator. So generator, it learn the generator get some random input and generate the plausible data, that is a sample. That sample will be given into the discriminator. like that. So here in that case, both the generator and the discriminators are the neural network. So the generator and discriminator are given in the pink color and blue color. So here the generator output is connected directly to the discriminator input, and through the propagation, that is through the back propagation network or back propagation algorithm, the discriminator's classification provides a signal that the generator uses to update its weights like that. So if either it will be discriminator loss or it may be generator loss. If it's a discriminator loss in the sense, again it will be given to the back to that the weight value will be updated. Based on that updation, again the discriminator will be working like that. So if it is a generator loss in the sense that again we are giving some random input, and based on that generator it will produce some sample, then again it will be given to the discriminator like that. So like that the GAN structure will be working. So this is a diagrammatic representation of GAN, that is a generative adversarial network. So next slide. Yeah. So as per see, already we have seen the previous diagram. We have seen about the what generator and discriminator. So but here how the back propagation in discriminator training is happening. So already I told you that if suppose a discriminator loss in the sense, that will be back propagated with the discriminator, and again that discriminator produces some output. That is we were giving some weight value will be given for the discriminator like that. But here the discriminator in a GAN is simply a classifier. Just keep in your mind, here the discriminator is act as a classifier, and it tries to distinguish the real data from the data created by the generator. So that's mainly happening in that thing. And it would use any network architecture appropriate to the type of data it's classifying like that. So as per that, here the discriminator training data, here the discriminator training data comes from the two different sources. One source is the, we may say the real data. Second source is the, we may say the fake data. That is a real image and a fake image like that. So the real image or real data instance, such as the real picture of the people. So here the discriminator uses these instances as a positive example during training time. That's happening in the real data. That is a discriminator. And the fake data instance is created by the generator. So the discriminator uses these instances as a negative sample during the training. That's a very, very important. So as per the generator will give some input. That's a random input is given. It will produce some output to the discriminator. So that is a negative example. As per the real data, it's a positive example like that. So in the figure 1 here, the two sample boxes represent these two data sources that feeding into the discriminator like that. So that's the things, two samples, one from the real and another from the fake like that. So during the discriminator training, the generator does not train anything. That's a very important thing. But its weight remain constant. The weight value will be remain constant while it produces the example for the discriminator to train on like that. So that's mainly happening in that discriminator. So next, how the training the discriminator. So how the training path will be performing in the discriminator. So the training the discriminator is nothing but the discriminator connect the two loss function. One is a discriminator loss, another thing is a generator loss. So during the discriminator training, the discriminator ignore the generator loss. That's the thing. Whenever the discriminator using that training in the sense, at that time the discriminator ignore the generator loss and just uses the discriminator loss alone. That's the thing. But we use the generator loss during the generator training. So whenever the generator is training, already I told you, whenever the generator is training, that's a fake data. Whenever the fake data is training, at that time only the generator loss will be, we are using it. So another important thing during the discriminator training. So during the discriminator training, these three things to be happening. First important thing is the discriminator classifies both real data as well as the fake data from the generator. So from the generator, it produces the fake data. Already the real images, that is the real data will be there. Both the thing will be given to the that is a discriminator. So the discriminator classifies both the real data and the fake data from the generator. That's the first point. Second important point in the discriminator training is the discriminator loss. Penalizes the discriminator for misclassifying a real instance as fake or a fake instance as a real, like that. So that's also happening. So the third important thing, the discriminator updates its weights through the backpropagation. That's why the backpropagation is performing. So it updates its weights through the backpropagation from the discriminator loss through the discriminator network. So that's happening. That is the main idea behind this discriminator. That is a discriminator loss. Loss will be what the discriminator loss will be updated with the help of the back propagation using the discriminator weights, like that. So that is the idea behind. That is the main thing how the discriminator training will be performing with the help of that back propagation. That is explained in the slide number 28. So next slide. Yeah. So here only we are focusing about the generator. Apart from the discriminator, the generator is available. Generator with the discriminator in that same side of the generator. So here the generator is the part of the GAN learns to create a fake data by incorporating the feedback from the discriminator. So it learns to make the discriminator classify its output as real. That's the thing. So here the generator training requires the tighter integration between the generator and the discriminator that discriminator training requires. So that's the thing. So previously the discriminator is based on the real data as well as the generator produces some fake data. Based on that, we are making the discriminant loss. So if the discriminator loss is there in the sense, that will be performing in that side only the back propagation will be performing. But here, as per the generator part itself, the discriminator is there. But here we are focusing about the generator loss. So that's the thing. So the portion of the GAN that trained the generator includes random input, generator network, which the generator network is nothing but which transforms the random input into the data instances. And another very important thing is a discriminator network. The discriminator network is nothing but which classifies the generated data. And finally, we are getting the discriminator output, like that. And apart from that, here mainly we are focusing about the generator loss. So the generator loss is nothing but which penalizes the generator for failing to pull the discriminator, like that. So apart from that, here we are giving the random input. So the random input is given to the generator. So the random input is very important. So the neural network needs some form of input. Normally, we input data that we want to do something with, like an instance that we want to classify or make a prediction about. So for that case, what do we use as the input for the network? That outputs entirely new data instances, like that. So in its most basic form, GAN takes the random noises as its input. So the generator then transforms this noise into a meaningful output, like that. So by introducing the noise, so some noises will be produces in that cases. So by introducing the noise, we can get the GAN to produce a wide variety of data sampling from the different places in the target distributions, like that. So as per this experiment, this generator and discriminator with generator loss, this experiment what it gives that the distribution of the noise doesn't matter much. So we can choose something that's easy to sample from, like a uniform distribution, like that. So for the convenience, the space from which the noise is sampled is usually of the smaller dimension than a dimensionality of the output space like that. So that is the generator. So next slide. Yeah. So here your first slide number 30, please. Yeah. Here your first GAN. So how as a first experiment with the generative adversarial network, you will implement the example. So to run the example, you are using you are going to use the PyTorch library. So as per that in the Python, we are having the PyTorch library, which you can install using the Anaconda Python distribution and also the Conda package and the environment management system. So to learn more about the Anaconda and the Conda, check the tutorial on setting up the Python for the machine learning on Windows like that. So here as per that, Anaconda is nothing but it's a full distribution of the software in the PyData ecosystem, including the Python itself along with the binary of several third-party open source projects like that. So here the first one we are creating. So the to begin create and Conda environment and activate it. So with the help in the shell mode, with the help of that Conda create name GAN and Conda activate GAN like that. So with the help of that, it will be activated. So as per the second figure we are installing the the second figure. Just we are installing the PyTorch library. So after you activate this Conda environment, your prompt will show its name as a GAN. Then you can install the necessary packages inside this environment like that. So these are the things happening as per the first GAN experiment. So next slide. So here, based on these two things, we are installing our PyTorch. So since the PyTorch is a very actively developed framework, so here the API may change on the new releases. To ensure the example code will run, you install a specific version. 1.40, 4.0 is a specific version. So beside PyTorch, you are going to use a matplotlib. So the library, matplot library, lib to work with the plots and a Jupyter notebook to run the code in an interactive environment. So doing so, it's not a mandatory, but it facilitates working on the machine learning projects some better manner. So in the first, as per the picture one, to do that, with the GAN environment, it activated and run the following command. That is we have to run the command is Python yum and that IP kernel install user and the name and the GAN like that. So that will be performing. And now you can open the Jupyter notebook by running the Jupyter notebook. Create a new notebook by clicking the new and then selecting GAN. So as per that, here we are making the import torch and from the torch import NN and import math like that. So inside the notebook begin by that importing the necessary library. So these are some of the library, torch library and math library is important for our GAN purpose. So here after that, here you import the PyTorch library with the torch. That is in the second slide, second diagram. You also import NN. That is a NN is just to be able to set up a neural network in a less Regressive way. So for that is import NN is nothing but for setting up the neural network algorithm. So then you import the math. So math for importing the math. Import math is mainly useful for to obtain the value of the pi constant, and you import the matplot plotting tools as a PLT as usual like that. So as per the third picture, the torch.manual of seed 11. So here it's a good practice to set up a random generator seed. Why? Because as per the GAN model, it's a generative and discriminator. It's used based on that random data only. So for generating that random generated seed, that experiment can be replicated identically on any machine. So do this that by PyTorch run the following code, that is a torch.manual _ seed of 111 like that. Here the number 111 it represents the random seed that is mainly used to initialize the random number generator which is used to initialize the neural network weights. That's a very, very important thing. So the triple one is very important. That triple one will be useful for initializing the random number generator, which is used to initialize the neural network weights. So that's mainly happening. That we have to install all the way these things based on that GAN will be activating. Next slide. So these are the way. This 2 to 3 slide will be it's explained about how to install that GAN. Yeah. Next very important thing: impressive applications of GAN. See in this section, I want to review a large number of interesting applications of GAN to help you to develop any research for the types of problem where the GAN can be used and useful like that. So it's not an exhaustive list, but it does contain many examples, uses and uses of GAN that have been in the media. So we will divide this application into the following area. The first one is generate the examples of image data sets. Second one is the generate the photographs of human faces. Third one, generate realistic photographs. Fourth one, generate the cartoon characters. Fifth one, image to image translation. Sixth one, text to image translation. Seventh one, semantic image to photo translation. So these are the some of the applications. That is the impressive application based on the GAN. So next slide, we will see about the generative example for image data sets. Slide number 33. Yeah. So the first impressive applications of GAN is to generate the examples for image data sets. So here in this example, generating new plausible samples was described all the way. First, some digital sign like that, faces, different examples will be given. So here where GANs were used to generate the new plausible examples for the MNIST handwritten digit data sets. That next thing is small object photograph data sets and the face data face like that. So that will be best example. So here the examples of GAN used to generate the new plausible example for image data sets like that. So that is a different way. There are different object is given, different faces is given, different data, the handwritten data digit data sets is given. So based on that, we adjust the the image data sets, generating the example for image data sets in the GAN applications. So next one, second example, second important impressive applications. Yeah, here generate the photographs of human faces. But this diagram mainly this slide mainly demonstrates the generation of plausible realistic photographs of different human faces. So they are so real looking. In fact, it's a fair to call the result remarkable. As such, the results received a lot of media attention. That is also here happening. So here the face generations were trained on the celebrity examples. That meaning that are there are elements of existing celebrities in the generated faces. making them seem familiar, but not quite like that. So that's what's happening. So here the example of different photorealistic example is given, but here it's improved quality, stability, and also variation. So the second best example, that is a impressive application, generate the photographs of human faces like that. So next slide. Yeah. So third one, it generate the realistic photographs. As per this, it demonstrates the generation of synthetic photographs with their technique. That technique is called as a big GAN. Big GAN, indistinguishable from the real photographs. So that is the best example. The example of the realistic synthetic photograph generated with the big GAN that are practically indistinguishable from the real photographs like that. So that is the third generate the realistic photographs. That is the third impressive application based on the GAN. The next one. Yeah. Fourth one, generate previous one. Slide number 36.
PPT number 36.
Yeah, yes. Yeah. So the fourth important application based on the GAN is it generate the cartoon characters. So mainly demonstrate the training and the use of the GAN for generating the faces of that animate characters. We may say example that Japanese comic book characters like that. So next is the fifth important application is the image to image translation. So just we are translating image to image. So this is a bit of a catch-all task. It's a very important. This fifth application is very important. This is a bit of a catch-all task for those papers that present the GAN that do many image translation tasks. So it demonstrates the GANs, specifically their pix-to-pix approach. So for many image-to-image translation tasks like that. So here the example include, in this case, the example include the translation tasks such as just we are translating the semantic images to photographs of cityscapes and buildings, translation of satellite images, satellite photographs to Google Maps, translation of photo from day to night, translation of black and white photographs to color, translation of sketches to color photographs like that. So that is a very image to image. So as per that image processing, this image to image translation with GAN, we will do lot of things. It's a very best example of that image processing application. That's the we will do lot of translation for the images. So next, sixth important application. Slide number 38. Yeah. So the sixth application is a text to image translation. So the text is given, just we are converting text to image. So as per this diagram, it demonstrates the use of GAN, specifically the stack GAN. So here we are using stack GAN. And the stack GAN is used to generate the realistic looking photographs from the textual description of simple objects like birds and flowers like that. So from that it will be converted into text to image translation. That is another best example with the help of the stack GAN. So the stack GAN is the best example for converting text into image translation like that. So next one. Next application. Yeah. So here, mainly the advantage of generative adversarial network. So mainly they demonstrate the use of the conditional GAN to generate the photorealistic images given a semantic image or a sketch as the input. So here there are so many specific examples. Previous slide, 39, slide number 39. Yeah. So here the slide number 39. Here the GAN generate the data that looks similar to the original data. GANs go into the detail of the data that can easily interpret into the different versions. So it is helpful in doing machine learning works. By using GAN and machine learning, we can easily recognize the trees, street, bicyclist, person, and parked car, and also can calculate the distance between the different objects. That's already I told you. Whatever the image processing, easily we can do the GAN with machine learning. Easily we can do all the machine learning applications without that machine learning operations like that. So that's a very important thing. So here the specific examples included is a cityscape photograph, bedroom photograph, human space photograph, human face photograph with the semantic image or given sketches like that. So next slide. Yeah. So next, previous slide, slide number 40. Yeah. So what are the different uses of GAN? So the GANs are helpful in marketing, advertisement, e-commerce, games, hospital, etc. And also we can generate the images for the novels and other story writing styles. And GAN are mostly used in the generating images and videos also. That's a very important. That's all the way we will do the image processing as well as the video processing also with the help of the GAN. That's a very important example or important application we may say with the help of the GAN and machine learning. So next. Yeah. So, so far the final part. So far we have seen about machine learning overview of that machine learning overview of GAN and how to implement the first GAN and what are the different impressive applications. So as per that, the final thought of this presentation, here the machine learning algorithm. It's learn from the data to find the hidden relations to make the predictions as well as to interact with the world like that. So the machine learning is intelligent is intelligent use of data to answer the questions. So whatever we are asking, that it will that will be happening with the intelligent use of the data to answer the questions. That will be with the help of the machine learning, and also enabled by an exponential. It increase in computing power and data availability also. That is also a very important thing behind machine learning. So the machine learning algorithm is as a good as its input data. Whenever the good model plus bad data, the model is good, but the data is bad in the sense automatically we are getting the bad result only. So whenever the machine learning algorithm is as good in the sense the good model as well as the good data is very important thing. So here the GAN, the Generative Adversarial Network, are a very active research topic with several exciting applications proposed in the recent years. So nowadays, so many applications, so many research activities are going on based on the GAN with the machine learning. Keep an eye on the technical and scientific literature to check for the new application ideas like that. So thank you so much. Thank you for our cooperation. Thank you. Thank you. Any queries?
Balakrishnan sir, Professor Balakrishnan sir.
Yes.
Sir, we will send you
Yes.
the questions, and I think you will mail the answers after that. Okay, sir.
Yeah, sure.
Okay, thank you,
Surely I will
sir.
do it.
Thank
Surely I
you,
will.
Professor.
Thank you so much.
I am Nis Kumar Sharma on behalf of IT Department, ABS Engineering College, Ghaziabad. A very heartily vote of thanks to you for gracing the event with your presence and sharing your finding and opinion about the GAN, Generative Neural Network. Thanks a lot, sir. Thank you, sir.
Thank you so much. Thank you so much. Thank you. Yes.
I am sharing the
Yeah,
feedback
please.
form. Please
Yeah.
fill feedback form. Participant, please fill the feedback form. I am just sharing it. Okay, I think I have already shared. You can see it in the chat box window. Please fill the feedback form and you can leave. Thank you all. Now I'm going to end the meeting. Thank you.